All right, we have three different learning targets that are going to be part of this section. First is we're going to calculate reference angles, and we'll switch to IXL to practice those. Then we're going to determine in which quadrant trig functions are positive, negative. This is like common ACT question, a way to ask you a trig question without asking you too many details about trig. And we'll play a little game where you just hold up. Normally I would play a fly swatter game where we all come up to the board and we get in each other's business. But with COVID, we'll just be holding up our fingers 1, 2, 3, or 4 for the quadrants. And then we're going to fill out our unit circle. So after today, the goal will be to know the unit circle, to be able to memorize it. And there's a little online game that we can practice our unit circle as we go through this. And then you have 2 different homework worksheets for homework. So let's get started with a little bit of a warm-up. So I have an angle theta here, and I've labeled it x, y, and r. This is leading up to kind of what we're going to be doing today. So there's a reason why I used x, y, and r as our sides there. Since this is my reference angle, my main angle here, my opposite is the y value, my adjacent is the x value, and my r is the hypotenuse. So you'll notice, right, with sine, you don't have to write out that it's opposite over hypotenuse. I think at this point we know that, but go ahead and fill out all of the other values using that triangle. Right, since sine is y over r, we know cosecant is r over y. Cosine is adjacent over hypotenuse, so it's x over r, and then secant is just my reciprocal, so r over x. And then tangent is opposite over adjacent, so y over x, and my cotangent value, I simply flip-flop those as well to get x over y. Questions on SOHCAHTOA? Hopefully everybody in this room at this point is feeling a little bit better about SOHCAHTOA. So our first learning target is called a reference angle. So as we build this unit circle, we're going to want to focus on some of the major angles, like 30, 45, 60, 90, 0, like all those angles that keep coming up over and over again. So what we do in the world of trigonometry is we try to make it easier by using what's called a reference angle. So a reference angle is the acute angle formed by the terminal side of theta and the x-axis. Okay? In your notes, does it have this next one, this thing for making a bow tie? Next fill in the blank here? Okay, good. I want to make sure. So a reference angle is always a positive number. Okay? And it's always going to be between 0 and 90 degrees. So when I say think of making a bow tie, this is what I mean. So we've got our coordinate plane here, and if I have an angle here, it's the distance down. If I have an angle here, it's the distance up to the x-axis. Same thing on this side, and then same thing on this side. So because I'm always just trying to find the distance from that angle to the x-axis, it's always going to be a positive number, right? We always kind of measure distance as a positive thing. We're just trying to figure out how close am I to the x-axis. So there's kind of your bow tie idea, if it helps to kind of encourage that thought process. So let's find that reference angle found by all of these. You may need to sketch these, right? You may need to give yourself a visual so that you know where you are on the coordinate plane. If I had 150 degrees, right, I'm over here. So how far am I from the x-axis?
30 degrees.
30 degrees. Perfect, right? You're going to use like the major idea that we've got a 0 degrees here, or 360, and over here we have 180 degrees. So you're going to keep coming back to those numbers. How far am I away from the x-axis? Questions on that? Okay. Let's look at the next one. Negative
50 degrees?
130 degrees. So what'd you say?
50 degrees.
50 degrees. Perfect, right? We need to draw a picture. Negative 130 degrees is down here, so I just have to figure out how far am I away. What about 280 degrees?
80 degrees.
80 degrees. Right? For 280, I'm down here, right? I'm right after 270, so I've got to figure out how many degrees does it take to get up to the x-axis. All right, now let's throw in some pi's.
Pi over 4.
Pi over 4, that is right. So if this is 0 and this is pi, and I'm at 3 pi over 4 here, I am pi over 4 away from the x-axis.
2 pi over 3. 1 pi over 3.
Yes, 1 pi over 3. So Justin's already ahead of us, right? This is 0, this is pi, this is back around to 2 pi, which 2 pi is the same thing as 6 pi over 3. So if I'm down here at 5 pi over 3, I'm just pi over 3 away from the x-axis. All right, let's go ahead and pull out our IXLs. And in IXL, make sure you're in Algebra 2. We're just going to do a little 5-minute challenge of Y6. Leave it to Y6. So hopefully everybody's got that pulled up. Go ahead, start your 5-minute challenge. Let's see how high we can get. It might not even take us 5 minutes, as we're just practicing our reference angles. So IXL Y6. Y6. Y6, not Z6.
Oh,
Like
that's why I looked at it confused.
Yes. Let me know if you want my help with any of these. I don't think they have them in radians on IXL, but you guys are always the first class to do it, so a little bit of a guinea pig situation here. Username Riley Edmonds 75. Password Redmonds 22. All right, time's up. Who's got our high score? Matthew, what do you got? 80. Anybody beat 80? Kevin? 88. 90? 90, you're our winner. All right, congratulations. Come up and get a candy choice.
One more question.
5 minutes.
That's
I got M&M's, lunch, and you got a nice
down 30. Okay.
I know, such is the way it goes with Excel. Okay, so that's reference angles. Let's go ahead and draw out kind of a diagram that we've got here. This is your typical trigonometry question. Like if you end up taking pre-calculus and trigonometry, this will probably be one of the first questions that you are asked to do in that class. So the terminal side of an angle in standard position passes through the point 3, -6. Draw the reference triangle and evaluate the 6 functions. Okay, so the first thing I do is I draw a picture. Okay? I put my coordinate point there. I have 1, 2, 3, down 6. Right, here's my coordinate point. Not drawn to scale, perfectly fine. I connect my origin to that point. Now, when we talked about reference angles were always between that side and the x-axis, right? So it's important to make sure you label theta in the appropriate location. It's right there. I then finish kind of drawing my triangle, and I say, okay, the length up here of my adjacent side is 3. And then the length of my opposite side, I'm going to write as a -6. And I'll show you why, right? We want to keep positive, negative signs with us as we travel along for this ride. How can I figure out the length of my hypotenuse? A squared plus b squared plus c squared, okay? We're going to come back to the Pythagorean theorem here. So we have 3 squared plus -6 squared equals c squared. So I get that c squared is equal to 45, which tells me that my square root, c is equal to the square root of 45. So they're a perfect square that divides into 45. 9 is 9, right? So I get the square root of 9 times the square root of 5. So I get 3 square root of 5. Think of all the math we're doing at this point, right? Think of the expectation that is on you guys to be able to do all of this. We haven't even started answering the questions, which what are all the trig identities? What are the trig ratios for this particular theta? But we at least have everything filled in. No decimals, only radicals allowed on these. So let's go ahead and start filling out what we know. So if I want the cosine of theta, I do adjacent over hypotenuse. So I get 3 over 3 square root of 5. Well, I've got to simplify this, right? I have a 3 divided by a 3, so those 3's are going to cancel each other out. So I have 1 over the square root of 5, right? Hoping I would be done there. I'm not. I have to multiply by the square root of 5 over the square root of 5. So I get that cosine is equal to the square root of 5 divided by 5. Now let's do, that's for us for all 6. So let's go ahead and do secant. Since we know cosine, we can figure out secant, right? Secant is just hypotenuse over adjacent. So I have 3 square root of 5 divided by 3. My 3's are going to cancel out, and I just get the square root of 5. Questions on that so far? All right, let's keep moving on. We'll do sine next. So the sine of theta is going to be opposite over hypotenuse. I run into the same problem where I'm going to have to simplify. I get negative 2 over the square root of 5. Multiply, and I wind up with negative 2 square root of 5 over 5. Am I going too fast? Okay. All right, cosecant. Let's find sine's partner in crime, cosecant. I do 3 square root of 5 over negative 6. And I get the square root of 5 over negative 2, or negative square root of 5 over 2, however you want to do that. All right, we've done 4. Let's do tangent and cotangent. So the tangent of theta, opposite over adjacent, negative 2. And then cotangent, we've got negative 1/2, or negative 3 over 6, which simplifies down to negative 1. So this is a loaded question, right? We had to understand reference angles. We had to understand Pythagorean theorem. We had to know what was going to be positive, what was going to be negative. And we will talk eventually about how we can shortcut some of these ideas about what things in which quadrant are going to end up being positive or negative. Questions? Okay. So let's talk about this, right? How we figured out from that list there that tangent, and therefore cotangent, sine, and therefore cosecant, ended up being negative in that particular quadrant. Let's see if we can kind of simplify this a little bit. I always kind of like to draw a triangle here. So basically what I'm going to do here is I'm going to use our warm-up. I have a triangle. It's in my first quadrant here. I have a coordinate point out here on a circle that has a radius of 1. Yep, do you guys have this small little circle? Not the big one.
No, we just have this cross.
Empty space.
Okay, draw a circle. I must have inserted a circle so that I would have a nice round circle so it looks nice. Okay, so draw a circle to the best of your ability. Because we're leading up, yes, to the big unit circle. I don't want us filling it up yet. But a unit circle has a radius value of 1. Okay, so my hypotenuse is going to be equal to 1. I know that for certain. Now let's talk about this coordinate point out here, right? It's the coordinate point x, y. They're both positive, right? We're in the first quadrant, so both x and y are going to be positive. The adjacent side here is equal to your x value. The opposite side here is equal to your y value. So let's figure some things out. We know that theta is right here. What is the cosine of theta given my diagram I have here?
X over 1.
X over 1, which is just
X
sine of theta.
Y.
Just y, right? Y over 1. If you want to put the y in there, you can. But this is like the fundamental part of why it's important to know our unit circle. Because this is no longer the point, xy. It is the sine of theta, the cosine of theta, sine of theta. So as I move around the unit circle, those coordinate points we're going to actually interpret them as the cosine and the sine of the angles as we go around our circle. So think of it, right? XY, alphabetical order, cosine, sine, alphabetical order. Okay, and when you have that unit circle on the test, you're going to have all of these cosines and sines filled in as you go around. So let's talk about quadrant 1. We label quadrant 1 as all. We're going to have like a little acronym that helps us remember this stuff, okay? In this quadrant here, cosine is positive, sine is positive. Now how about tangent? Well, what is the tangent of this over here?
X over Y. Oh, Y over X.
Y over x. But what's y? We know what y is. It's the sine of theta. We know what x is. It's the cosine of theta. This is one of the most important trigonometric identities, and we just proved it ourselves. The tangent of theta is sine divided by cosine. So if I'm doing a positive number divided by another positive number, tangent is also going to be positive in this quadrant. This is important, but I need my space here, so I'm going to relabel this here. All right, let's look at our second quadrant. We call this all, and here's our acronym, students, because it tells me which one of my trig identities is going to be positive. In this quadrant, sine is positive and cosine is negative, therefore tangent is negative. Why in this quadrant, in quadrant 2, is sine the one that is positive?
Because sine is Y and Y
Because
goes.
sine is y, and y is positive in this quadrant, right? All my y values up here, they're all positive. All right, let's look down here. Take. All students take. In this quadrant, the only thing that's going to be positive is tangent. Both sine is negative and cosine are negative. Right? The reason being, in this fourth quadrant down here, both my x and my y coordinates are negative. And we have a negative divided by a negative, we wind up with a positive. And then our last one is classes. Or you can come up with your own acronym, right? There's lots of different ones out there. It's really ASTC. So in this quadrant, cosine is positive, sine is negative, tangent is negative. The reason being, right, in this quadrant down here, my x value is positive, so therefore my cosine value is positive, but my sine is going to be negative. That's what we saw with the previous example. Questions on this? All right, we're going to play a little hold up your fingers game. So these are your four quadrants. 1, 2, 3, and 4. We usually use Roman numerals to represent those quadrants. So we've got 1, 2 finger, 3 finger, 4 finger. And I'm just going to read out a statement. You can have your notes in front of you. We'll see how we do. All right. The only quadrant where sine, cosine, and tangent are positive. Yep. How are you doing, Kai?
What is that? What'd you say?
The only quadrant where sine, cosine, and tangent are positive. There we go. The only quadrant where sine is negative and cosine is positive. Sine is negative, cosine is positive. You can just do this. Yes, perfect. You just do quadrant 4. I appreciate the Roman numeral thing. The only quadrant where cosine is negative and tangent is positive. Tangent is positive. Cosine is negative. All right, the finger game is working. I see it. I can yep, okay. The only quadrant where tangent is negative and sine is positive. Tangent is negative, sine is positive. There we go. Quadrant 2. All right, the only quadrant where cosine and sine are both negative. That's right, quadrant 3, we got it. Give me a quadrant where tangent is negative. Tangent is negative. We've got 2 or 4. I would accept either answer, correct? The only quadrant where cosine and tangent are negative.
Oh.
Cosine and tangent are negative. That's right, quadrant 2. And our last one, our only quadrant where cosine is positive and tangent is negative. Cosine positive, tangent negative. All right, I think we got it down. Good job there. Okay, let's go back to our fun notes. Right, do you guys have these questions at the bottom?
Yes.
So, when it asks you to evaluate without using a calculator, by the end of this class, you're probably going to pick up your unit circle and do this. But right now, we know enough to be able to calculate this just by using a reference angle and our understanding of what's positive and negative. Okay? So, what is our reference angle for 210? 30 degrees. Look at the very first page of your notes. What's the sine of 30 degrees? Or you can put it in a calculator, perfectly fine by me. What's the sine of 30 degrees?
5 or 6.
1/2.
1/2. You're talking about
I see.
radians. 1/2. So the sine of 30 degrees is 1/2. So what quadrant is 210 degrees in? Quadrant 3. So therefore, is sine negative or positive in quadrant 3? Negative. So the sine of 210 degrees is negative 1/2. This is why I say memorizing your kind of main angles here becomes really valuable. Yep.
Wait, I'm confused. How did we do the 1/2 and put it in like quadrant 3?
Okay, we figured out our reference angle for this. 30 degrees. The sine of 30 degrees, that's one of those things that we should have memorized at this point. Well, I know maybe not at this point. Hopefully by the end of the unit, but you will. Sine, cosine, and tangent of our main angles 30, 45, and 60 is what I'd like us to memorize by then. Okay? Since I know the sine of 30 is 1/2, and it's my reference angle for here, I just have to figure out what quadrant is 210 degrees in. In the third quadrant, and all students take classes tell me that in that quadrant, that sign is going to be negative. So it's like building your way through the question. These are the type of things I encourage you to have, like this self-talk, right? I'm going to talk my way through figuring this out. I know, it is what it is, right? All right, let's look at our next one. Negative pi over 6. So what is my reference angle?
2 pi over 6. 1/3 pi.
How far away am I from the x-axis? 1/6 of a pi. I'm pi over 6 away from it. All right? The cosine of pi over 6, or 30 degrees, if we want to think of it that way, is square root of 3 over 2. I'll just tell you that. Which quadrant am I in? What quadrant is negative pi over 6 in?
No.
All right, let's find a coterminal angle. Let's find a coterminal angle. We're not doing well with our negative. All right, how do I find a coterminal angle, meaning the same angle, but hopefully it'll be positive this time?
You add 12 12 pi over 6.
I add 2 pi or I add 12 pi over 6. Perfect. So what do I get?
11 pi over 6.
11 pi over 6. So where is 11 pi over 6 on our circle? Quadrant 4. So we're in quadrant 4. Another way to think of it, right? If I'm negative pi over 6 down, it's right here. Right? I clockwise rotate away. So in quadrant 4, is cosine positive or negative?
Positive.
It's positive. So therefore, it's still a positive square root of 3 over 2. That's kind of the long way to do it, I will say that. Although finding a coterminal angle when you kind of get stuck, you're not sure where to look on your unit circle, that's not a bad approach. Right? That's a good approach. Let's go ahead and tackle the beast. We're going to fill out our unit circle. Circle. All right. A unit circle is a circle with a radius of 1 that is centered around the origin. Okay, we're going to build a lot of stuff here. The cosine of theta is going to be your x value, so your x coordinate, and your sine is y, right? So we have cosine sine or xy. So we're going to fill out basically what our coordinate points are as we move our way around the unit circle. And you're going to want that table from the very first class that we had that has the cosine and sine of all of our kind of major angles. So make sure you know where that is in your notes so you can flip-flop back and forth. Because we've already proven those things. Whether or not we have them memorized, that's okay. There is a Quizlet for it. But we will kind of use those as we go through. All right. First things first, let's fill out our degrees and therefore our radians. Let's see. Do you want me to keep with like the 2 different colors, the blue and the red? Does that help? No, you don't care? Yes, you do care? Does anybody want colored pencils? Yes, no. Whatever helps you to keep it straight, okay? Feel free to come up and grab some colored pencils. I'm going to kind of first, start with just the kind of black lines here, our quadrants. So I have 0 degrees, or 360 degrees, or 2 pi, you can think of that. Up here we have 90 degrees, or pi over 2 in radians. Then we have 180 degrees, or pi in radians. And then down here we have 270 degrees, 3 pi over 2 in radians. So, first thing, right? What is this coordinate point right here? If I have a radius of length 1.
0, 1. Or 0, 0.
1, 0. Right? The x part first and then the y part. Up here is 0, 1. Over here we have -1, 0. And then down here, 0, -1. Right? Because we have a radius of 1, we can identify those points. So right now, if I ask you, without looking at your table, what is the sine of 90 degrees?
0, 1.
Which part of the coordinate point do I look at for sine?
The y
Is it
part.
the x-coordinate or the y-coordinate?
So
the
one.
y-coordinate. So the sine of 90 degrees is 1. The cosine of 90 degrees is 0, right? This is how we're going to end up using our unit circle under reference. Okay? Let's go ahead and do our 30, 60, 90s. I'll do them in blue to kind of keep with what we did last class. And I know I don't have the lines drawn over here. I do apologize. Do your best. They don't have to be perfect. So we have kind of all of this stuff filled out on the previous page in terms of radians and degrees. But let's go ahead and fill them out. We've got 30 degrees, 60 degrees, 90, 120, 150, 180, 210, 240, 270, 300, 330. Your unit circle will be worth 4 summative points. The first summative point is if you get all the degrees right. So just by filling that out with our degrees, there's our first summative point. Now let's fill out our radians as we go around. Remember, we're going to count up by pi over 6 as we go. So we've got 1 pi over 6, 2 pi over 6, which simplifies down to pi over 3. 3 pi over 6, which we already have identified, 4 pi over 6, which we simplify down to 2 pi over 3, and then 5 pi over 6. We're going to keep going. We've got 7 pi over 6, 8 pi over 6, which is 4 pi over 3, 9 pi over 6, 10 pi over 6, which is 5 pi over 3, and then back around to 11 pi over 6. We have not filled out the x and y coordinate points yet. We're just putting in radians and degrees from our last time. All right. Let's talk about these coordinate points. We'll put in the 45 degrees in a second. What is the cosine of 30 degrees? Huh?
1/2.
No. Check your table. What's the cosine of 30 degrees? The very first table, first page notes. What we got? Square root of 3 over 2. What is the sign? Now you got it, Peyton. 1/2. So, for 30 degrees, I have the square root of 3 over 2, comma 1/2. Right? That is the coordinate point that refers to, what I did is I tried to kind of draw this triangle here if we were going to kind of rebuild it. But we've already proven this. We've already proven why the value of cosine of 30 degrees is this. We use special right triangles to do it. Okay? Let's look at 60 degrees. What's the cosine of 60 degrees? 1/2. And then square root of 3 over 2 is your sine value. Perfect. So now we're just going to take these values and kind of reflect them around our unit circle as we go. So I have my 60 degrees here, and now I move to 120 degrees. What's my reference angle for 120 degrees?
30 degrees.
How far away is 120 degrees from my x-axis? 60. So I look at 60 and it tells me, okay, this is the same coordinate point. I just have to figure out which one of these is going to be negative. Well, in this quadrant, x values are negative, so I have negative 1/2 square root of 3 over 2. But that's how we use our reference angle. That's how it's supposed to help us as we go through these.
That's fancy.
I go to 150 degrees. Now, what's my reference angle for 150?
30.
I look to 30 and I say all I have to do is copy this over and figure out which one is negative. Again, in this quadrant, the x value is negative, so I get negative square root of 3 over 2 and 1/2. Now, hopefully we're kind of figuring out the pattern, right? What's my reference angle for 210? 30 degrees. So I just used these same values, but in this quadrant, everything is negative. So I have negative square root of 3 over 2, negative 1/2. Down here at 240, my reference angle is 60, so I have negative 1/2, negative square root of 3 over 2. I'm going to keep going around. My reference angle here is 60 degrees. And in this quadrant, the y coordinate is negative. And then last but not least, square root of 3 over 2, negative 1/2. Questions on those? The 45-degree angles are much nicer. You'll see why. I know. Big circle here. We've got 45 degrees or pi over 4. Here. Trying to make it fit so you can actually read my handwriting. We have 135 degrees or 3 pi over 4. Down here, 225 degrees or 5 pi over 4. And then 315 degrees or 7 pi over 4. Hopefully everybody can read that, or you've got it on your paper from what we did in last class. Now for all of these, right, we just only drew 4 points. Every single one of those points has the exact same reference angle. They're all 45 degrees. So once we figure out what this value is here, I just can think of positive, negative as I go around the circle. So looking at your table from that first day of class in here, what is both the sine and the cosine of 45 degrees? Square root of 2 over 2. So that's why I say it's a little bit nicer, because then all I really have to worry about is what's negative or positive as I go around the circle. Whoo-wee. And we have done it. So now that we've created the unit circle, right? No, I don't necessarily do this with my regular class versus honors class, right? The expectations are high here. Now we can hopefully use this as a reference to answer questions. Now, hopefully, right, on your notes, you at least have the unit circle on one side and then the questions next, so if you can kind of have those side by side. In mine, they are not, so you'll just have to keep going back and forth for 2. So right here on this unit circle, you've got degrees, you've got radians, you've got sine, you've got cosine. What do I not have on this unit circle here? Tangent. Tangent is the only thing that is missing from this whole thing.
Yeah.
So unfortunately, when you get tangent, we're going to have to do a little bit of math. We're going to have to do sine divided by cosine, or you can memorize those numbers from that table that we first filled out. So tangent is going to be sine divided by cosine, which means we're going to have to do some fraction math as we go through it. So we got this. So let's look at our first question here. Oh, I don't even have it pulled up. There we go. We've got pi over 6. All right, so I'm going to make us fill out a bunch of stuff just to make sure we know how to do it. What is pi over 6 in degrees? It's on your unit circle.
30.
30 degrees. So what's my reference angle? 30 degrees, right? It's a number between 0 and 30. It's positive. We've already figured it out. So when I look at my unit circle, what is the sine at 30 degrees, or pi over 6? 1/2, right? We got to look at the y coordinate. You got to look at the y value on your unit circle. What is the cosine of 30? Square root of 3 over 2. Now the tangent of 30 degrees, like I said, you have two options. You can memorize it from that first table we did together, or, and we're just going to do the math out so we can see it, right? If tangent is sine divided by cosine, that's why I asked you in this order. We're going to say the tangent of 30 is sine 1/2 divided by cosine, square root of 3 over 2. And of course, right, let's all remember how to divide fractions. We keep the first, change to multiply, flip the second. I get 1 over the square root of 3, which is square root of 3 over 3. That's probably the longest one that you will see, which is why I encourage you to potentially memorize those. If you have those reference angle, sine, cosine, tangent memorized, it'll help you out quite a bit. Oh, and we were supposed to draw a picture. Sometimes this helps, right? There's where pi over 6 is. Alright, 5 pi over 4. So 5 pi over 4, and my weird ellipse that I have here. Alright, it's like halfway down there. What is the degree of 5 pi over 4? 225. What's my reference angle? It's always 45 degrees when we're working with those, right, the ones in red. So what's the sign? I heard it first. Almost. Negative. This is where the negative positive comes into play. So in this quadrant, right, both sine and cosine are going to be negative. And here's a nice one. If tangent is sine divided by cosine, if I have the same thing in my numerator and my denominator, it's just 1. Perfect.
Yay.
All right, negative 90 degrees. Right, this one I actually gave us an angle in degrees at this point. So just reminding us that if I have a negative degree, it just means that I go down in a clockwise fashion. So if I'm looking at my unit circle, what angle do I need to be looking at? Because there's no negative 90 on there. 270. 270 degrees. Now my reference angle at this point just happens to be 90. I'm as far away from the x-axis as I can get at this point. So what is the sine of 270 degrees?
-1.
-1, that's right. What is the cosine?
0.
0. Ooh. What is a number divided by
Undefined.
0.
Undefined.
Undefined.
If I divide by a 0, and if you look back at your original notes, right, what was the tangent of 90 degrees? We got an error, and we didn't understand why. Now we understand why, right? We cannot calculate a tangent if there's going to wind up being a 0 in the denominator. You guys want to try 4 and 5 on your own?
Yes.
Give them a whirl. Give them a whirl. -4 pi over 3, right? Maybe I'll get us started. We're going to be over here. Right, so we're rotating clockwise. This is where maybe finding a coterminal angle. I know, I said I'd let you guys do this on your own, so I'll stop bugging you. Cosine is your x coordinate.
So sine is the x.
No. Cosine is your x coordinate. Sine is your y. Yep, they're in alphabetical order. It's not
If you said find the coterminal thing, 2 squared or 2.3 is the same as.
okay, find the coterminal angle. Add 6 pi over 3. Over 6 pi over 3 minus 4 pi over 3 is pi over. Oh, you gotta move that denominator along the way, right? 2 pi over 3. Okay. I wrote these as 100 right? So I can figure out where on the unit from it, but that's what and now these are not the sine and cosine. These are my 269. So it shouldn't be square root. Alright, why don't we come back together? Make sure we're doing this right. Alright, so here's the thing, right? You can definitely count your way around the unit circle clockwise instead of counterclockwise. If you do, you want to be in sixes, right? We're always counting in terms of 30, 60, 90 in terms of sixes. So I would have made this negative 8 pi over 6. So I go 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. These are all negative. 7 pi over 6, 8 pi over 6. So I'm up here. Okay, my reference angle in this case is going to end up being 60 degrees. What I did though is I don't like working with negative degrees, so I calculated a coterminal angle, right? I added 2 pi to where I started so that I would find something that was exactly on my unit circle. 2 pi over 3 is on my unit circle. I can just use all that information from 2 pi over 3. My sine is square root of 3 over 2. My cosine is negative 1/2. So from there, if I do sine divided by cosine, I get out negative square root of 3.
No. Go ahead.
Okay? And then our last one, because we don't want to forget about 0. 0 can still be technically an angle, right? It's not very exciting. Right? My degree of my angle is 0. My reference angle is 0. What is the sine of 0 degrees?
0.
Cosine.
0.
What's 0 divided by 1?
1.
0.
0. So I am allowed to have, in this case, a tangent because I don't have a 0 in the denominator.
Yeah, why is cosine 1?
Because it's that coordinate point. If I have a radius of 1,
Oh.
what is this? So I know, right? Believe me, this is a big leap. Today's class, you guys have just learned like the foundation of trigonometry in one class. This is a lot of material. I totally understand it. But as long as you start to realize that all of this is something that over the course of the last 3 sections, we have proven that all of this stuff exists. So trust that this is correct, and now we're going to have to practice it a little bit. I know that you guys probably want to work on homework, but I would like to introduce you to the unit circle game online so you can practice this while you're at home. So hopefully everybody still has their computers out and about. I put the link up on Google Classroom so that everybody would have access to it. It is called the unit circle game. So when you click on it from Google Classroom, it should just take you to this page. And hopefully I can kind of close all these ads. You can click this kind of start game button. And so it's going to ask you to fill in this information as you go. And you're going to get the green and the red. So there's a couple things, and I always forget about it too. They have like one where it's positive and negative quadrants. Can't remember. Let's play it. Let's see if we can practice this. Okay, so this one, I'm guessing, do they not have, this looks a little bit different from what I'm used to last year. This is a team game? All right, so if it's just asking me to find 240, okay. 360, is it this or this? Okay. Ooh, 11 pi over 6. Ah, see how it's filling in half circles? This is definitely new this year. Then they're having you fill in, so they have all, last time they used to just have the first coordinate points. There we go. No, don't want to do that. All right, so what you do is they're going to give you these questions over here, and they're going to ask you to kind of fill them in on the coordinate plane as you go. I also just have paper copies of this worksheet on the unit circle that I'll pass around so that everybody gets a copy of this. But this is a nice, like you're sitting at home and you want to practice where things get filled in. I recommend doing this, especially as you're first learning. So your homework assignment are those two worksheets that I've already handed out to you. You have 10, 15 minutes to work on them.